Okay. We have 45 minutes, that's true, I think. So it is now 12:01. And do I even have Wi-Fi? Is there Wi-Fi? Let's find out. Maybe. Hey, cool. Well, whatever. I did a lot of work yesterday, like Steven Spielberg. I did a lot of work because I was scared the Wi-Fi wouldn't be good. And I'm going to use that work no matter what, because like the whole day, just drinking and doing this. Lots of vodka, lots of vodka. So, but I care. It's because I'm dedicated. So anyway, before we get started, something super, super important. Let's make sure we get this out of the way up front. Can you please say open source? Oh, that's so good. That's so good. Thank you. Spasiba. Very good. Right, so my name is Josh Long. You can tell because it says, well, it says Josh Long, so there's that. If you have questions, comments, feedback, that's my email, that's my Twitter handle, GitHub as well. So if you have anything you have questions about, please do not hesitate to send me an email. I am at your service. I don't want you to leave more confused than when you started, okay? I am the developer advocate for the various Spring technologies at Pivotal. How many of you have heard of Pivotal? So Pivotal is we're a new company. We started in April of 2013. We are the new home of Spring, of Cloud Foundry. How many of you have heard of Cloud Foundry? Okay. And Redis. How many of you have heard of Redis? RabbitMQ. Okay. We have a Hadoop distribution. We have Apache Geode. We have a bunch of different technologies. And we care about building modern applications that support modern workloads. And a big part of that is building applications that live in the cloud. We provide a cloud. We have a platform as a service called Cloud Foundry. It's open source. You can use it for whatever you want. Because it's open source, other companies, other small companies have taken our code and they have built their own clouds on top of it. So how many of you have heard of IBM? IBM? IBM. IBM. Okay, not many, not many. That's okay. They were a company that was pretty interesting 40 years ago. They have a technology called BlueMix. How many of you have heard of BlueMix? That's Cloud Foundry. Okay, that's based on our technology. How many of you have heard of HP? HP, another startup in the valley, small. You know. They have something called Helion. Helion is based on Cloud Foundry as well. So these big, startups that are 40 years old or 100 years old are building their cloud businesses on top of Cloud Foundry, which we created. And we have our own distribution of Cloud Foundry as well. So we care about that. We care about how to build applications that live and work correctly on top of the cloud, on top of the platform as a service. About me, I'm an open source guy. I've, contributed to lots of different projects and technologies, author of 5 books. My latest book and my latest video training are all about how to build applications that work and live on the cloud using microservices and using Spring Boot and Spring Cloud and so on. So I care about this stuff a lot, and of course Cloud Foundry is a huge part of that story as well. Here's all the cool stuff at Pivotal. So when we talk about applications today, we talk about microservices. A lot of us look to companies like Netflix. Netflix is a big, big company in the West, and they have some great advice for companies that want to grow bigger and to be able to scale in their applications. One of them is deploy containers, right? What they really mean is consistency is important. Your application is not a snowflake. Every application changes from one use case to another, but they all look from the operations perspective the same thing, right? So Docker is one kind of container. People used to use Tomcat as a type of container because it's just a way of managing it, starting, stopping, deleting, etc. A platform as a service is a cloud that lets you think about applications. You're not thinking about processes. You're thinking about applications. You're not thinking about Linux and RAM and hard disk space. You're thinking about applications. You're thinking about databases, message queues, and the applications. So it's a consistent way to build and deploy applications. And if you understand how to do it once, then it's easy to get everything else to work there, right? The other thing that's important is that you have to remember when you move to the cloud that servers are not your friends. They are not pets, right? If you have a name for a server, that's bad, right? We do that. We have like a host name. It's like, oh, well, this is George. Well, in the cloud, you have to be able to kill George. George has to die, right? So it's very important to think about clouds as cheap, disposable resources, okay? Failure is going to happen. Build your software to scale. So if you saw my talk in the beginning and this morning, we talked about microservices. This is an architecture for building apps that are resilient to failure. When we talk about platform as a service, I think this quote is the best I've seen. It's a quote from 2011. Imagine if architects, how do you say that in Russian there? Architects?
Architecture.
Yeah, something like that. Is that okay?
Yeah.
Oh, that's my favorite word in French, architecture. So imagine if architects had to be the janitor for every building that they designed, right? If you, as a software developer, when you build systems, you don't sign up. You're not interested in also having to tail the logs and rotate logs and make sure that memory's okay and do monitoring. That's not what you're interested in, right? Why do we care about this? Why doesn't the platform do all this stuff for us automatically? So don't be the janitor for your applications. Okay, so that's enough slides. So I worked very hard yesterday. Like I said, lots of vodka. And I was worried about Wi-Fi, and since everything I'm going to talk to you today about is cloudy, I was worried that I would not be able to get it all done fast enough. So I'm going to play a video. There we go. We are going to look at moving a simple application. This is an application that I'm going to build using Spring Boot. You can see here I'm choosing web, I'm choosing JPA. And this application is going to be very simple. I've actually demonstrated it earlier today. If you saw my first talk, it's the same thing. So I'm going to bring in Actuator, which gives me the operations, metrics, health and check, all these different things that I care about. I'm going to choose Java 1.8 because today is 2015. It's not 2010. I'm going to hit generate, and then I'm going to open the code for that. And I'm going to build a new application using Spring and Spring Boot. How many of you saw my talk earlier on Spring Cloud, which builds on Spring Boot? So then you know that it's very easy to build an application today that does something interesting, right? So I'm not going to spend too much time on this. We're going to look at a couple of different technologies in this talk, but we need an application to play with. So I'm going to build something very simple here. Let's see. This is just a regular Maven build. I'm going to open it up in my IDE. Just out of show of hands, how many of you use Eclipse? Okay, Eclipse. Anybody? Nobody. There's nobody using Eclipse. Oh, okay. What about NetBeans? There's always one person. Oh, there he is. It's that one guy. Follows me in all my talks. So what about IntelliJ? Who here uses IntelliJ? Gee whiz, that's incredible. Cool. That's like the majority. That's the first time I've seen it. I've seen it like 60-40, 40-60, but whatever. So I'm building a regular JPA entity here. I don't want getters and setters, so I'm going to use getters, okay? I'm going to create a primary key. I'm going to add an entity annotation because it's JPA as well, right? And this is just an object that I want to be able to display over REST. And I want to be able to deploy, manage, scale this application. The application is not the interesting thing here, though. What is interesting is how we're going to manage this, right? If you think about the cost associated with managing and deploying applications, most of that cost is after the application has been deployed. It's after it's been developed. So we're going to spend a very small fraction of this time today looking at me build some code. But this is not the interesting thing that we care about. Instead, we're going to care about how to make the rest of the life of that application better. Okay, so this is a Spring Boot based application. I'm using Spring Data to build a repository. and I'm going to expose it over REST automatically. You see I've got @param. I'm saying that that finder method, find by reservation name, should be exposed over REST, so I can say, localhost :8080/search/ find by reservation name (RN equals) and then the name of the person. I'm going to create a bean that will just load some dummy data, okay? Just a command line runner. This is a callback interface, so whenever command line runner is seen on any bean that Spring manages, it'll be invoked when the application starts up, and it gives me a chance to do basic data initialization. Because I was by myself and I was drinking, I did the right thing. I used a constructor here. Now, this constructor is the right way to build object-oriented code, right? But if you're like me and you're on stage a lot, you're doing demos, you'll see people do field injection. I'll say @autowired private, reservation repository or whatever. Don't do that, okay? Every time you do field injection, a unit test dies. It dies. And so if you want to murder an innocent unit test, that's what you would do. But don't do that, okay? Good, so I'm saving some data. And then now I want to actually, what do I want to do? I'm going to print out all the data just to make sure it's working. I'm going to say find all, get all the records that come back, and then I'll print out everything that I get back from the database. Again, I'm using an embedded in-memory database. This is going to be H2. As we're about to see, I don't necessarily have this already pre-configured, but I'm going to try. I'm going to try and do database access without a database. I'm not the smartest. So here we go. I'm also going to configure a few things so that when I move this application into the cloud, it'll automatically generate the SQL for my data source, okay? So right now it's going to be embedded in memory, but when I go to the cloud in a bit, I want to actually talk to a live database that my cloud will manage for me. So I have to tell Spring Boot to tell Hibernate to generate the DDL and to do all that stuff manually for me. There's two properties. Generate DDL is generic. If you want to specifically use the Hibernate version, there's a sub-property that you can use, but you don't need to use both. I'm just doing it for completeness, okay? So, let's see, does that work? Review, could be good. Let's see what happens. Maybe. Okay. Just making sure things are cozy and safe. Run. Here we go. The suspense is killing me. Is this going to work? I have no idea. I mean, look at that ASCII artwork. That's always a promising sign. It didn't work. Remember what I told you? I was trying to call a database that doesn't exist. So in order to create a database, I'm going to go to my build, and I'm going to add H2, which is an embedded in-memory database. For my local development, this is great, right? It's very fast. Spring Boot will see that I have an embedded in-memory database on my class path, and it'll create a data source, and then I can actually, the Maven has to be re-imported. So just rebuild one more time. See? Rebuild one more time. Good ASCII artwork. This is key to success. It's very important. Oh, that's good stuff. Okay, so that worked, right? I've got my data. If I go to my local host, my machine, I can actually see that the data's all there as well. So localhost :8080/reservations. Great. There's all the hypermedia, right? This is an implementation of hypermedia, or hypertext as the engine of application state, HTOS, okay? But this is not really what I want to do, right? This is, and I'm going to go ahead and, what am I trying to do here? I want to expose the ENV endpoint so we can see which host and port the server is listening on another IP, right? By default, I added the actuator. The actuator exposes information about the state of the application. This information is good for operations, so I can see what's happening. I can see the health check. I can see how many beans there are. I can see the environment. I can see all these different things. But they're only available by default through localhost. Since we're going to do applications and push them to the cloud, I want this information available publicly, right? Since I'm trying to prove that this is all working. So I'm exposing them now, okay? This is very convenient for understanding what's happening and for debugging. If you're building cloud applications, this feature is critical. To have it, you just add Spring Boot starter actuator to the class path. Okay, now, let's move on. First things first, make it bigger, please. Thank you. Good. Can you guys see that, hopefully? Oh, phew, because it's not going to get much bigger. It's too small a laptop, so that's the problem. I couldn't really, my old eyes, you know. So what I want to do is I'm going to deploy this to Cloud Foundry. See, CF push, and I'm specifying the path to the jar, and I'm saying give it a random route. This is the URL. Cloud Foundry has many different hosts, right? It's an open source, so you can run it in your data center, or you can run it on Pivotal Web Services, or you can run HP Helion, or you can run IBM BlueMix, or any other dozens and dozens of different Cloud Foundries. I didn't show you that here, but you can specify that I want to talk to Cloud Foundry running here, or Cloud Foundry running over there. So you're specifying a target. I've already specified that, and what I'm doing now is I'm telling Cloud Foundry, here's my jar, please run it, right? I'm saying, give it a random URL as well. What I'm doing here is I've actually used the magic of Hollywood special effects to make this go by much faster. Because if you were with me yesterday, and it could have just been the vodka. It could have been the vodka, but it felt like forever. So I used Adobe Premiere to make that time go like just 10 seconds or whatever, very, very fast. So now the application is now running on beautiful-enunciatory litigation cfapps.io. Okay, it's running on the cloud. I've already pushed my application successfully to Cloud Foundry. And now, remember, I'm using an embedded in-memory Java database. I want to actually have a real database because this is not just a toy. I want to actually talk to a real Postgres or something. How many of you use Postgres? How many of you remember MySQL? Anybody here remember MySQL? Many years ago, there was a database called MySQL. And it's a thing. So I just used CF Marketplace. Did you see that? Marketplace is a list of all the services that my application can use. So Load Impact, IronMQ, Elephant SQL, Cloud AMQP, New Relic, Blaze Meter. These are all different types, Memcache, Cloud for caching. These are all the different types of services that my application can connect to and talk to. I want a database, so I'm going to say CF create-service, Elephant SQL. Well, I'll let him say it. He's faster. So I'm going to specify the plan. Turtle is the free one, right? It's different levels, turtle and other animals. The free one is turtle, and I'm going to name it Beautiful-PG. This is a Postgres database that I want my application to talk to. Then I'm going to say CF services to see which database services I have. You saw that my Postgres was there. Then I'm going to bind my Postgres database to my application. My application's name is Beautiful. So I'm going to say, connect this database with this application. Then I'm going to restart the application. I'm not going to do anything else. I'm just going to restart it. Cloud Foundry is going to see that I have a Postgres database, which is a javax.sql.data source if I want. And it's going to automatically replace my embedded H2 database and point it to Postgres. Hello? Oh, it's you. Oh, it was those dreams again. So I'm restarting the application, and you can see the application's up and running. You can see it says number 1, number 0 is up and running. Great. It's at the same URL. But now, since I've got a real application, I can refresh it, I can hit the same endpoint, everything is still working. If I view the reservation information, that's all still there, but now it's actually being written to the database, right? So each time the application starts up, it writes data to my Postgres database. As you'll see later on, when I restart the application, it keeps on adding more data, the same records, right? Because in the code, I actually wrote like five or seven records when the application started up. I've only got one instance of this application running right now, however. So if something happens to that server, remember George? Remember our friend George, the server? If he dies, what happens? So I want to scale out. I want to make sure that my service is highly available. So I've just added 3 more instances. I said CF scale, Beautiful, -I, 3. And that tells Cloud Foundry to add more nodes to actually just load balance the services automatically for me. So you can see here, there's my environment endpoint, and I have the Postgres credentials. You can't see it, but it says Postgres, and there's my username and password. Don't connect to that, okay? And there's all the information automatically bound to my application. I didn't have to redeploy the application. I didn't have to change it. I just created a managed service on the cloud, and I'm telling Cloud Foundry, please make my application aware of it. Look at the port. See where it says 61461? This is the port. There it is, 61271 again. This is the port on which 404, 61461, etc. So this is the port that my application is listening on. I have 3 instances, so as I do refresh, I get different instances, round robin. Now I have 3 nodes for the same service. I'm going to go ahead and add a terrible, terrible, terrible controller here, a REST controller. Again, don't put this in your code. This is not a good idea. This is sort of like the worst idea ever. Okay? Well, I mean, there are worst ideas. Have you heard of PHP? PHP? Yeah. Don't do that. I mean, do this first. This is way more productive. Okay? So I'm going to create a kill endpoint. And all that's going to do is it's going to kill George. Okay? So, yeah, thanks for the reminder. System.exit -1. And I'm going to redeploy this application. I'm going to rerun it and prove that it works. And then I'll push it into Cloud Foundry. And we're going to see what happens when I murder George. Savagely. I want to destroy George. So, Maven clean install, rebuild, application is working. Okay. Come on. Good. CF push. I'm updating the application now. I'm saying go ahead and update Beautiful. I'm passing in the same jar that I deployed before. So to deploy and to update a jar is the same command. Okay? It sees, oh, you want to pass that jar, you want to upload it, great. It's going to stop the existing one and then start it again with a new code in place. And you can very easily do red-green deployments. You can do all these things very automatically. You can say this application lives at this URL. You can push an application over here to another URL and then automatically switch the URL from the existing app to the new app that's running and then kill the old ones. This is lightning quick, very, very fast. So now I've got 3 instances up and running. They're all there, they're all happy. Up and running, good, 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 move on. I think we're just pausing for dramatic effect, making sure that we all appreciate what just happened here. Now I'm going to go to my browser, and I'm going to visit one of the instances. So I'm going to ask Cloud Foundry, hey, where does my application live? Well, it lives at beautiful enunciatory litigation.cfapps.io. You can see that I've started 3 of them. Remember what we talked about earlier? Each time it starts up, it keeps on adding the same data. So Oleg and Artem and Rod and Aryan, they're all in there like 3 times now, right? Because it keeps adding as I restart. So there's 21 records now. 3 times 7, that's about right, 21 records. The port is still doing the right thing, so you can see it's, port is changing just like before. Probably different ports, different hosts, but we don't care, right? The application is up and running, it's alive, it's responding to requests. This is a little awkward. Wish I hadn't included this part. Maybe next time I won't. Okay, let's kill it. Let's kill George. So I'm going to call /kill on that port. I called kill. I'm going to keep on asking Cloud Foundry, how many applications do I have? And it says 3 out of 3, 3 out of 3. Now it says 2 out of 3, because I killed one of them, right? The heartbeat, the cloud, is doing a heartbeat on each of these instances, and it sees that one of them is down. George is dead, okay? And then it restarts George, so that George can live. So that's why it says 3 out of 3 again. See, registered endpoint, failed to open the request, blah, blah, blah. So I just killed it again, and so on. So you can see, if an instance goes down, if there's something wrong, the cloud will make sure that these apps are up and running again. You don't have to worry about that. You get all that just for free out of the box. So now, of course, I have 28 instances, right? So 4 times 7 is 28. That's what happened. I had 3 nodes, and then I added 1 more when I killed the existing one, okay? So this is all just handled for you automatically. If this was all a cloud gave you, though, this would be not a very interesting story, right? How many of you have used a platform as a service like Cloud Foundry or Heroku or Google App Engine or a Windows Azure or something like this? Beanstalk. There are many options out there. This is open source, so that's why I like it, but you can choose whatever you like. Let's see. So we've got an application. Again, it's doing the basics of a platform as a service. It's able to restart, manage, and operationalize your application. I'm adding more nodes. I just added another node, so that's all there as well. What I want to do is understand, I want to see the environment variables for my application. So remember, I created a Postgres, so I want to see what the connection information is for that. So I can say cf env for the application Beautiful, and then look for Postgres, and it'll give me the information, and I can connect to the cloud-managed Postgres from my local machine using pSQL if I want. That's not super interesting here, but what I want to do is connect to the dashboard at run.pivotal.io. This is the home page where you can get your account. So you can get a free account for a month, a trial here, or you can run it locally. I have an account already. Actually, this is a little awkward, but I work for Pivotal, and they wouldn't give me a free account. Which bothers me, because I give talks about it, you know? I was like, what the hey? And then finally, after a year, they gave it to me. But for the longest time, I was paying for my own Cloud Foundry, because I have apps that I want to run, you know? My own apps. That's why I have 2 different organizations here. So Cloud Foundry is very smart. You can actually set it up for different teams, just like GitHub. You can be part of different organizations. So anyway, there's my application. You can see the health and the status and how many instances. It's green right now, but if it was something was wrong, it would be red. You'd see a red circle there. You can see how many instances, their health, the RAM, all that stuff. You can add or delete memory. You can add or delete instances. You can do whatever you want, all from this dashboard as well. So it's very operator friendly. If you're an operations person, then this is something you care about, right? Very easy ways to fix things. You can get an event log. You can see all the JSON that I've just shown you as well. All of this is available and visible. You can map DNS, routes. It's very easy to add different routes, and you can map them to different subdomains. You can use your own DNS and register it, and then point this to the A name for that, etc. You can see the logs inside of the run.pivotal.io, right? You can actually look at all the logs for all the different instances. But my thing is that I want to actually analyze my logs. Remember, an application up and running is only useful if you can learn from it, if you can learn from the patterns. So what I want to do is actually point it to something that I can use to analyze my logs. How many of you have ever used syslog-d? Syslog, it's very common for log management. It's a protocol. It's a process, but there's other services that accept that same protocol. So Splunk, any hear of Splunk? Or Papertrail? Papertrail? Okay, well, whatever. There are many different web services that will do this for you. So it's a syslog protocol. You just forward your data to that endpoint. So what I've just done is I said cf create user provided service, beautiful logs -l. Then I said syslog : / logs to papertrailapp.com. This is a web service that I can host. I get a free account, but I can also pay more for more log management. And I've created a user service, a custom service, and I'm going to bind that service to my application. Cloud Foundry will see that this is a syslog service, and it'll automatically forward all the logs for all 3 of those instances to that web service, where I can do more advanced log analysis and so on, right? So all my apps are now running. I've just restarted it, and I've told it about the log service that I want to use. And awkward pause. Not sure what happens next. Go logs. Mer? Well, this is a bummer. Oh, never mind. Good. So eventually, I put in a very awkward pause in there. I'm not sure what I was expecting to happen. Maybe some dancing or something. Oh well. I'll do that for the next time. So you can see that the log is now bound in the services tab on my application. I can go visit the application itself. I can go see the logs for the application by going to papertrailapp.com. I've already connected my app on papertrail.com, and so I can go see now the logs for all the things that were printed out. But this is a separate web service. I'm able to ship all the logs for all of my instances on Cloud Foundry to this web service, and then there's a search field inside that app where I can actually do things like searching and analysis and do more useful performance monitoring and analysis and so on. So I can actually type a search down there and say, show me all the logs that said this or said that, right? So down there I could actually search for, well, I don't know, something, reservations. I'm just going to search for / reservations and just find all of the requests that went to / reservations. Again, this is very powerful if you're trying to figure out what happened and where and so on. The next thing that, if you want something more advanced than log analysis, how many of you have heard of or used New Relic? New Relic. It's an application performance monitoring service. And so I'm going to go to the Cloud Foundry marketplace again, and I'm going to create a New Relic instance. It's a web service, and what you do is you deploy it as an agent for your Java code. It also works with PHP and Python and Java and Scala apps and Ruby and anything, right? They have clients, they have integration for all these different languages. And the best part about it is that it'll sit there as a Java agent, and it'll intercept everything that you're doing in your code and time it and make it so that you can now analyze what is happening in your application. So I'm going to say CF create service, New Relic. I'm going to use the standard tier, the free tier. I'm going to create a name. I'm going to say give it the name Beautiful New Relic. Then I'm going to bind my application Beautiful to this New Relic service. Then I'm going to restart the application again, and then we can actually go create traffic and then see what's happening in New Relic. Now again, New Relic is used by huge companies with billions of page views. It's very, very good for understanding where your users are spending time in each request, right? Each request that goes into the application, you want to understand what's happening and why it's taking so long. So I'm just going to restart the application again. I can see all three of them are there, that's fine. And now you can see, if you look on the output there, it says -d, New Relic, home, etc. It's all in the Java command there. I didn't have to change anything for the start script. It's all just automatically done for me. If I refresh my services on the dashboard, I actually have a list of all the different services that are there, and now you can see New Relic is there. I click on the Manage link, and it's going to take me to New Relic directly, right? And it's going to say, okay, well, you can look at the data on New Relic's website. So I've clicked on Manage, and it's going to show me this thing that I love right there. See that? It says, welcome data nerd. Very polite. I'm going to click on accept, okay, and now I'm logged into the dashboard for my application. I can see anything inside of New Relic here about my application. I can see, no, I don't want to send you validation or feedback, thanks, but we just started. So there's my application. You can barely see it. It's a bar that says Beautiful, and it's going to show me this is my application that New Relic is monitoring. This is actually Beautiful right there. I hit refresh, and now it's got green, so it means it's getting data. I'm going to go to my application and hit request. I'm going to hit refresh a few times to drive traffic into the application. And then as I go back here, you can see it's updating already. It says 3.3 RPM, request per minute or whatever so far. The application has been up and running for 34.9 seconds or something like that. And there's the graph of the requests being sent into the application already. Right? So this is very much the same thing as we had before. But now it's much easier to kind of see what's happening. I can even see where things are going slow. I can say, in the servlet context listener, or going down to the Tomcat level, and then I can actually deep dive. I can say, show me the request breakdown by tier. Right? So here I'm showing you the outer container level stuff. I can look at the external services and see where, if anything, something is going wrong there. Nothing here. Great. Most time consuming. I can get a map of all the requests. Again, this is all just stuff that you're going to want when something goes wrong. It doesn't cost. It doesn't take away time from your performance on your application itself. It's very powerful. And go back. Applications, you can do this. Click on that. What I really want to show you is the breakdown. There's part of it. So that's the same information we saw a minute ago. Come on. Go left. Go left. Oh, sad. If I could just get that mouse to go down to the JVM section, that'd be interesting. You can see I've got 3 different instances. So you can see the RAM, the response time, the average response time, the request throughput, how much memory it's using, all of that stuff. I can break it down as much as I need to. I can understand which application is doing what. Again, all this stuff is something you want to have in your application. For me, the web transactions and the scalability in the database sections are the most interesting. So here's a breakdown of the requests into my application, and it actually knows about Spring. So it says repository entity controller, get the collection resource. And then I can actually see, oh, well, I made a request, and then the purple is the dispatcher servlet, the blue is the get collection resource, the green is the response entity controller, the yellow is the servlet request context listener, and then the light blue is other, which is not there. I can actually see at each level how much time I spent. I can even see the SQL query and how long that took. right? So I get this all just by binding the service to my application. It gives me the ability to monitor and measure everything in my application very, very quickly. So there's the Postgres select query, Postgres reservation select, etc. And again, I didn't have to write my code differently. I just deployed a regular Spring Boot application. Okay, let's see. You can actually see, by the way, there's the actual individual queries. You can see how long it takes and the request transactions and all that stuff. Moving on. Let's see. Cheating a little bit. Great. The last thing is that, okay. Nope. I'm moving back in time so that it seems more dramatic. Do it. Oh, this is so painful. So painful. You guys don't know what's going to happen next, though, right? Okay, brand new. So, go. So, what I want to do is I don't want to have to do all this again. So far, I've showed you how to add these services, how to add a database, how to add monitoring and log aggregation. But I don't want to have to do it again. The next time, I just want to have it like very, very simple. So you can create a manifest. That's what I did. Is I created a CF create app manifest. It gives me a text file which shows me the. It gives me a little text file here. Create app manifest. Great. There you go. It's saved to beautiful manifest.yaml. And I want to print that. I want to show what's in there, and you'll see that this manifest declaratively describes there. That it's declaratively describing how my application looks. I need this much memory, this many instances, this host, this domain, and these services, the Postgres instance, the logs instance, and the new Relic. All of that is described in a YAML file. You put that in your application, and then next time you do CF push, it'll just read it from there. So you don't have to re-describe it again like I just did. So it's much faster. You know, if you want to be able to move, imagine like a really, really complex application with 10 different pieces. You put a YAML file in there, and then do CF push, and then this is all just there. Okay, so this is a platform as a service. That's Cloud Foundry. I want to show you part of the future of Cloud Foundry. There's something called Diego. We've taken our Cloud Foundry code and rewritten it all in Go. And it used to be written in Ruby, like Heroku. How many of you have ever heard of or used Ruby? I'm sorry. I give away open source hugs. So if you've ever been abused by Ruby, I'm here for you. We have taken some of the cool features inside of Ruby, can't believe I said that. We've taken some of the cool features inside of the new Cloud Foundry and extracted them out into a small runtime called Diego. Diego is perfect for running container-based workloads like Docker. How many of you are using Docker? Something like it? Okay, so Docker is a declarative way of describing your application. Remember, when you're building it up, and what I'm doing here is I just git cloned Lattice, by the way, and I'm installing the command line tool, LTC, using wget, and I did vagrant up. Vagrant is a way of standing up a local virtual machine that inside of it has my entire Lattice cluster. So if you want to do a whole cloud on your local machine, that's super simple. Just do vagrant up. If you want to deploy it onto AWS using Terraform scripts, again, no problem. You can get it up and running in minutes. It's easy to get this entire cloud up and running. It doesn't have all of the operational features that Cloud Foundry has. It doesn't have users and management. So basically, if you're deploying to this cluster, you have cluster root, right? But if you want to see how this stuff is going to work, and you want to get started and get moving very, very quickly, this is super simple. So I've said LTC target 192.168, blah, blah, blah. And what I want to do now is I want to move my application to Docker and then deploy and manage that Docker image on Diego, or on top of Lattice, okay? Lattice is, like I said, it's the pieces that manage container-based workloads moved out of Cloud Foundry as a separate component that you can use today. So what I'm going to do is I'm going to give my Maven build, I'm going to tell it that the Maven build is going to be named whatever, and then I'm going to use the Spotify Docker Maven plugin, and I'm going to give it a prefix. So this is the name of my Docker Hub account, Starbucks man, okay? So it's like GitHub, you know, your organization. I'm going to give it a Docker image prefix. It's going to be called Starbucks man, and then just like on GitHub, underneath that you have different projects or Docker images, okay? And what I want it to do is to automatically build an image that I can then push to Docker Hub and then run on my Lattice runtime, my Lattice cloud, okay? So I've done nothing else. Oh, the only other thing I need to do is create source main Docker and then add a Docker file. And a Docker file is going to describe the command that's required to run this application once it gets started. So I'm going to say, okay, I'm going to use the Java 7, in this case I'm going to use Java 8, the Java 8 base image. I'm going to add the jar on my local machine to the container and call it app, and then I'm going to run it using Java -jar. Okay? So I'm going to do maven clean install, Docker build. This is going to build a Docker image using Maven, and then I can deploy that to my Docker Hub registry, where other people can consume it. I can also make it private, so it's just private to my organization. But you can see what it's doing there. It's actually adding all the pieces in the Docker image. And now I'm going to do Docker run. I'm going to tell it to run port 8080 inside the container and expose it locally. I'm going to tell it to run the image named starbucksman/reservations. That's the image that I just deployed to Docker Hub right now. And you can see it's running locally on my machine, so everything's okay. And now that we know that everything's working, it's very simple to then take that into Lattice or something like that, deploy it, scale it, and so on. We already saw me deploy Lattice, that was easy. So what I want to do now is I want to say, is my image running using Docker on my local machine? You can see it's running right there. Of course, I can kill it. Docker is really nice because you can isolate your different services. You can create Cassandra and MySQL and Postgres and RabbitMQ and whatever, run them in your local machine, and then see what's happening. And you don't have to dirty up your containing environment. So there you go, I just killed it. And now I'm going to do Docker push again with the updated image, just make sure everything's still working. And the reason people are moving to Docker, of course, is we have this need for isolation in building applications. Like I said earlier, a lot of us used to use Tomcat, right, for this consistent operational image. Tomcat is a well-known formula. We all know how to start, stop, delete, etc. images inside of Tomcat. However, what I have seen, and I'm sure most of you have seen this, we have one application per Tomcat. How many of you have just one application per Tomcat? Right? Yeah, I mean, it's pretty common because the problem is that, oh, there you go, oops, I moved a little too fast. Go back. There you go, I'm going to deploy, Docker run, good, moving it. Oh, I forgot I didn't include the one thing that would have helped here. You need to see LTC create Starbucks Man reservations. And what that would have done was deploy the Docker image called Starbucks Man reservations to my Lattice cluster, right? And Lattice can be running on Amazon, it can run localhost, which is what I have here, and that'll download the Docker image and then run it. And now, for some reason I skipped ahead in the video when I was editing this, that's a failure. And now, what it's going to do is it's going to scale that instance out. So I've pushed it again. For some reason, come on. It's all there. Great. And then you can see I did LTC scale, but for some reason I forgot to show the the LTC create. So scale Beautiful Lattice, scale it up to 3 instances. So now I'm scaling 3 Docker images on my cloud here. This is a very, very, very simple way to go. But again, it's Docker-based images, right? You can run anything. I'm using Java and Spring Boot because Spring Boot gives you a jar, and a jar is very easy to manage, right? The reason we used to use Tomcat is because it's something that we all know how to manage. And I remember, do you know who has the leadership for Tomcat for contributors here? Anybody? Pivotal, right? So again, it's the #1 most widely used application server by far, like it's not even close. The next, #3 is Wildfly, and that's like 30% of the market. So the rest of the market is all non-Java EE containers. Most of it is Tomcat. Sometimes it's Jetty. And here I am trying to tell you, use embedded Tomcat. Don't bother deploying to the server. And the reason is because we have seen that people want to configure things like SSL and things like that, and they commit the server.xml for their application. They commit the Tomcat configuration with their code. Sometimes they commit Tomcat itself, right? Which is disgusting. Like, what are you doing? But that tells us something. That means that for a lot of applications and a lot of organizations, the configuration for the container and the application, they're linked together. I'm going to only deploy one app to my container. So why is there this artificial separation? The concerns that I care about in my container are things that are specific to my application, and I want to customize them anyway. And so by using Spring Boot, all of these concerns become programmatic. It's very easy to manage your SSL, to manage your security, your ports, gzip compression, all that. It becomes something that you configure with Spring. Everything is just Spring. And then if you're using HTTP, great. If you're not, great. It's still just Java minus jar. How many of you are using an HTTP web server today of some sort in your applications? Right? Imagine if by some terrible, disgusting, horrible thing, imagine something terrible what happened in the past. And instead of building HTTP-based applications, imagine if we built FTP applications. So instead, if the whole internet was not HTTP, but it was FTP, would you feel okay? Would you feel proud building applications that you deployed to an FTP server? Imagine if Tomcat was an FTP server instead of an HTTP server. Would that feel right? Would you be happy to go home and talk to your family and tell them, like, yes, I deployed to an FTP server? No, of course not. My God, your wife would beat you. You know, it's a complete weird. It's a weird thing. So only in the Java community do we have this really, really bad disease where we take good Java code and then deploy it into these runtimes. We take Java and then put it inside of Java. You don't see PHP people trying to deploy PHP inside of PHP, right? They've got Apache, but at least that's blazing fast. You don't see Node.js developers trying to deploy Node.js inside of Node.js. It makes no sense. Just do it once. The operating system can provide much better isolation for memory and for security. It can provide much better ability to monitor and analyze what's happening. All these things are much better handled at a lower level. The container doesn't add value, and where it does add value, you can do all those things inside of Spring Boot, for example. So if you're trying to keep that application surface area as small as possible, and then consistently manage them, Docker plus something like Spring Boot is very natural. What I've just shown you today is how to use Cloud Foundry and how to use Lattice, two different technologies, but they're going to be the same thing eventually in a short amount of time, to deploy, scale, and run cloud-based applications. And you can see that by moving to this consistent cloud-based approach, you get rid of having to manage these details. You don't have to be the architect for the buildings that you design. Okay, that's the goal here. As developers, everything we do is based on a theory. Did you ever think about that? Everything that we do as developers is based on the theory that somebody's going to be happy with the features that we deliver. But you will not be able to discover this. You will not be able to validate the theory until you get to production. And as we've discovered over and over and over again, the thing that keeps us from production isn't the code, although that's part of it. It's all the other things that you have to do, like operations, like logging, like analytics, like performance management, like security. Move that into the platform. Let the cloud do that for you, right? That's the benefit here, is it gives you the ability to do continuous delivery, to be agile, and to reduce the time between having a theory and then proving it, validating it. Okay, so thank you very much for your time. Spasibo. I'm here to answer questions, and we'll drink otherwise. I think there's a panel. When's the panel? Does anybody here know? Friends?
Nikolai will announce it probably.
Nikolai will announce that there's a panel at some point. I think it's now, but I have no idea. Or maybe it's after lunch. When's lunch?
You are the one to know. It's now.
Oh, it's now. I don't know. So come to the panel. If you have questions about Spring and things like that, I'll be there. A lot of the other Spring speakers are going to be here as well. Thank you very much, guys. Cheers.